for coming out tonight for the last Nashville Data Nerds for 2020. It's been an interesting year, but I'm happy for everyone for us to find this way to kind of get together and still have a conversation about data, even in these kind of disconnected times. Without further ado, I'd like to introduce Diego and thank him for taking the time to speak with us tonight and lead a conversation about his NSS capstone project about scraping data around web streaming applications and how he turned that into a dashboard. So without further ado, here you go.
All right, thanks, Alex, and thanks everybody for coming. There's a little bit of bigger crowd than I thought, so that's really exciting. But
sorry, real quick. Sorry, I forgot to mention. To accommodate the fact that Zoom is very hard to have multiple people talking over each other, which I just demonstrated, if you have any questions or comments, please post them in the chat, and I will be moderating the questions and trying to find an ideal time to kind of gently interrupt Diego to kind of manage those questions.
Awesome, good to know. Good to know. That's helpful, and I'll try to create some chances for questions so you can jump in. Okay, so I'll start just with a little intro about myself and what my experience was and what you're gonna hear. So I currently work at Perception Health, a healthcare analytics company here in Nashville. I've only been there a few months since I graduated the NSS Nashville Software School program from the first daytime, full-time data analytics cohort that they had. So what we're gonna see here is what was my capstone presentation. Before that, just more background on myself. I from Florida, or Ecuador originally, grew up in Florida, went to the University of Florida, go Gators. Studied engineering, material science engineering, did some internships with that, ended up doing supply chain for a long time after college. And then while that had a lot of data analytics within it, I was mainly doing Excel for a long time. And I always kind of wanted I don't know, to get back to some more technical skills. And so that's kind of what led me to the NSS program, and loved it. And yeah, now I can show you guys a little bit of what I worked on, which is exciting. So I had a actual PowerPoint presentation. I think you guys, I sent out the links of my GitHub. So you probably maybe get a chance to see that, or if you want to pull that up, you can see that. I'm actually not going to go through the PowerPoint itself the same way I presented then, as I figured maybe people may be interested more in the technical aspects. So I wanted to focus on that. So I'll kind of be jumping around my Jupyter notebooks and the website I pull things from and explaining the technical aspects. And if we have time towards the end, we can walk through the presentation and a little bit about how I presented it to companies and kind of some of the motivations for why I chose my topic. All righty, I will now share my screen. All righty. There is a lot of things up here. Let's start. Whoa, I think I stopped it. No. No, there we go. Are you still seeing my screen?
Nope. No.
Okay, yeah, I think I stopped it. There we go. Okay, perfect. I might need to move this a little bit lower because the top of the Zoom thing is kind of blocking my tabs. Okay. So just with the end in mind, I wanted to just show you what my project ended up looking at the end. And I kind of had a vision from this from the start, and it just depended on what data I could find. So the purpose of my project was to create a dashboard that people could use to identify which streaming service was best for them. So I wanted them to be able to play with filters and see which of the most popular streaming services had the most offerings that they would be interested in. So I actually am super happy with how it turned out, because it's a lot of how I envisioned it in my head beforehand. So what you have here is and this is in Tableau public. We send out the link to that as well. So you can, again, feel free to play with that. The data is now outdated because I haven't rerun this, but so what you have here is all your filters here in this top corner, which includes which of the streaming services we're talking about, movie or TV show, rating, such as, if it's 18 plus, more mature, more for kids, genre, what kind of genre you're interested in. And you can actually get to search by title if you really care about one specific show that's your favorite and you want to see where that is, as well as you can see the year of that show or movie came out in, some ratings from Rotten Tomato and IMDb, just to say, take off the stuff that people don't tend to like. And then the country of origin of the show or movie is also here, and this map works as a filter. And then you get to the data. You can actually see pretty much the source data over here and what that particular show is on. So sometimes they're not exclusive and there are multiples. So that's what this little corner thing shows up at the end. This means it's on Netflix and Hulu. A lot of it, Hulu and Disney Plus. And then, so that's how you could play with this. If I care more about modern shows, I would narrow this down. You can see up here pretty much a count of movies and TV shows. And then the tree diagram kind of shows that as well in another graphic representation where the size of the box is what will tell you, oh, Prime has the most offerings that I care about. So then, you would just play with this filter and say, I'm, a big snob and I just like the best of the best. And I don't care if Rotten Tomatoes doesn't like it, I'm not gonna like it. And then I like more action and adventure, for example. Okay, so after playing with all of that, you could see, okay, it looks like Netflix would be best for me, and then Prime Video, and then Hulu, etc. And you can kind of see what this is, how these things look like here. So that's kind of the essence of the dashboard. We can play with that later. You guys can play with it on your own, so we have the link out there and it's published. So now I want to get to how I created this. The first thing, and I struggled for a while on choosing what my capstone would be because it all depends on what data is available out there. So then, and with some help of Mary and Mahesh, my great instructors, we found this website over here that is called Real Good. Actually, very, very cool. If you just want to know where your favorite TV show happens to be, I would suggest you go on here and just type out, like, for example, Scrubs was one that they removed it from Netflix at one point and I was heartbroken. And you can select it and I'll tell you, oh, it is now on Hulu and apparently Prime Video, which was news to me. But anyway, I'll give huge credit to this website and whoever puts it all together, because they've done a big part, which was combining and gathering all the information of where TV shows and movies are, which streaming service has what shows in them. So then the question after that is trying to pull the data from here. And I'm seeing a few comments up there. Is this a good time for some questions?
Oh, no, just fun banter.
Excellent. Okay. All right. I'll let you jump in then as needed. But okay. So we identified this this table that they show, and you can narrow down by service or if you want TV shows and movies, and they show you all the listings. Very, very cool website. I've since I did this project, I've gone in and searched for shows I was interested in many a time. So then it's a question of pulling this data. So one of the things, and one that I really enjoyed in my NSS program, was the web scraping section, where we figured out how to pull this information from the website. For that, I use Python. And let me pull it up. So if you see my Webscrape final workbook, if you went into my GitHub, you'll see kind of the put together, best put together version. There were a bunch of other ones because this is annoying me. Just because this took a lot of trial and error on my part. So you can see some of my kind of pre-work and then more nicely put together in my Webscraping final. But we use the requests package here, which pulls in the information from websites. Beautiful Soup is a package that lets you interpret that, after you get all that information, parse it out. So there's a lot of the HTML. And then pandas, NumPy, regular expressions, and I actually don't know if I ended up using this one as much, but these ones are kind of the critical packages that I use for this. So the first step would be to pull this information as a table. As you see, it brings in a table. Take that away, and then a big part of this is understanding how the website is created, and which is a lot of fun for me because I didn't have experience with HTML or web development before. So you can see as you load, the URL changes this to offset 50. So each page goes 50 by 50. So that's how you would end up getting all this, everything that you want by continuing to change that number. The next thing I had to understand is the HTML behind this. So if you right click and inspect any web page, you can kind of see the programming behind it. And understanding, oh, this went away from, oh no, it is now looking a little different, but let me try to get it back to a table form. It's not what it looked like when I did this. I think they've done some more work since, but all right, let's, yeah, they've definitely changed this website since I did this project. Anyway, back to when it was a table. Maybe if I click that, it'll go back to that. Nope. Let me go back to the regional. Let's just say on Netflix. Here we go, as a table. Perfect. This is the way it looks. You inspect the, nope, yeah, it changes. It maybe stays, will still work, but you can then either highlight areas that you're interested in by clicking here, and it'll highlight out here what where that is. So I click that, it'll take me to it. But the way I did it was by finding table. It would be that. Oh, it looks like it does change it once it goes into this format. But there we go. Maybe not.
I think when you're shrinking the page, it's defaulting to tile versus table.
Yep, it's absolutely doing that. As you see, when I opened it up, now it finds 9 instances of table, which is why, there we go. So apparently I can't make it smaller anymore, too much bigger to show you guys, but it finds table, and I had to understand this classes and how it's all built underneath. So we go back to my web scraping, and
Hey, Diego, real quick. So what resources did you use to figure out that these were the best Python packages for you to use?
That, and I remember when I presented to you, Alex, we talked a little bit about some other resources. That just happened to be what I learned in NSS. And so I was applying what I learned to it. Now I know that there are some better, or not to say better, but different packages that can do web scraping, and I just did not have the familiarity with that. So I used what I learned in class. But maybe at the end you can give some of the suggestions that you had given me on other packages that would be useful.
Oh, and that was from someone attending the meetup, not personally myself.
No worries. Yeah, I figured you were jumping in with their questions. Okay. Any other questions we want to get out?
One, Pam is asking, how long did it take for you to scrape the data?
I don't know if you're asking for, and you remember my answer to that, but this took me 40 hours where I just had my computer running. And one particular step is the one that took that big amount. And I'll show you guys here where that is. But yeah, that was a pretty nerve-wracking weekend when I just clicked run on my Python script and had to leave it there thinking and hoping that it didn't crash or that my power didn't go out or something along those lines. But all right, going back into this, again, if this was a lot of trial and error, which you can see in my other packages, but in my final kind of well put together notebook, I created a function that would take in the base URL, and it's kind of described here, and then just a string of which service I'm using, and I'll let you know what it uses that for. But what this does is it goes into that base URL and it pulls in those tables and all the information from it, and then it's a while loop so that it can continue doing that for every page in that table. So the way that works is I create this variable and set it to true. I create this offset as 0, and that's, if you recall, comes from my understanding of the web page as I explore it, where it changes the offset to 50, and then as I keep adding for the next page, it continues to add that. I also had to test that if I put 0, it'll take me to the first page, and lucky for me that worked, because otherwise I would have to figure that out as well. So I start my offset at 0. I create an empty data frame to pandas, and I set my a base URL as real good. And actually, no, forgetting if I use this or just whichever I pulled in. Maybe that's extraneous. But okay, in my then I create a loop where which is going to continue as long as my my keep looping variable is set to true, and that's what's going to allow me to kill the loop later when I find out that I've gotten to the end of the pages. I turn that to false, and then my loop would end. So then first the response, I create a response variable using the requests function that uses the base URL that I inputted and adds that offset at the end of it, starting with 0. And so it gets that as a response. Then Beautiful Soup takes all that HTML and turns it into something readable, which we call a soup, or at least Beautiful Soup does. Then Soup has this find all function that lets me, yeah, let's say function. I don't think that's the right term for it. I'm forgetting the right term, but method is find all method that lets me find specific things from HTML. In my case, from exploring the website, I knew a table with these attributes. That's what would return the table that I found. Now, this will actually return a list of tables. So that's why I call it table lists. So if in my website there happen to be multiple tables in the HTML, it would create a list for each one. In my case, our web page, again, from exploring and then trying to understand the HTML behind it, I understood that only one would be there for any offset or for every page of the table. So then I make a if function that says if the length of my list of tables equals 1, that means that a table was found. So I'm not yet at the end of my of the pages. Then I'm gonna run this code. So it's going to pull, I read HTML and pull a list of data frames. So from my table. And then I'm gonna make a data frame and call it the page data frame. And from that list, pull the first one. So that finally creates the first 50 listings from my table into it.
Hey, I've got a quick question. So Armel is asking, could you talk a little bit more about what you're doing with a base URL and how you're augmenting it, and why this works?
Absolutely, absolutely. So the base URL, as I mentioned, was this part here. Essentially, brings over here, and it looks like maybe they've changed this to on Netflix since. But imagine this offset is 0 here, which was my starting point. That gives me my first 50 listings. So as I mentioned, but this goes on forever and ever. Not forever and ever, but it's a humongous listing of, I think it had like 26,000 rows. So I needed to be able to find those first 50 and then keep continuing on to find the next 50 and so on. So that's where that offset comes in. At 0, it gives me the first 50. And then I learned from exploring the webpage that when I go to the next step, it adds 50 at a time. So each page in my table would be 50. So I'm gonna build that into my loop where I'll grab the first 50, and then I'm gonna increase the value of that offset from 0 to 50, from 50 to 100, so that I can find all the pages in my table and put them all together. And you'll actually see that up here. So there was one more aspect here that I needed to talk about. One difficulty, and this is the part that made it take 40 hours. One difficulty is that this table here is very nice. It gives me my ratings, my scores, the year, and some of the nice information. But in my head, I was not happy with that being the only information I could filter by. I really wanted genre in there, and unfortunately, that was not in this main table. So then what happens is I need to click on this, and then you get extra information for whatever that listing is. And that's where this next part of my code comes in. I struggled a little bit to figure out how I was going to do this, what was the best way of pulling all that information so that I could get more of the filters that I wanted in my final dashboard. Let me see. This will be useful to look at my original notebook. So when you first pull in that table as is, this is what you get. You know, there is a column for this picture. There's a column for the title. And, you know, there's a few extra things in there that I don't quite want. And that makes sense because that's what this table looks like. You know, you get here, and the title itself actually has the link enabled. And actually, you could click on the title or the picture, and it will take you to that extra information. So that became very important in my web scraping. So next thing I do here is this next few lines, as I put in my comment, is to get the links in there. I figured out that the way I was going to do this is I'm going to pull all the information from the table, and then I'm going to have Python click on each link to come and get additional information on it. I had originally thought of maybe pulling that in from other sources that maybe would just list a genre, and I was looking at this other website, and then I would have had to deal with how do I match that the title here matches the title over here so that I can pull the information. That seemed like it'd be very challenging as well if they don't have unique identifiers, or they deal with special characters differently. So I decided that it was best to stick with just pulling it from Real Good. They have that information. I would just need to figure out a way of pulling it from each individual page for each listing. So that's what the next lines here do. It finds me the HTML or for the table. And I needed to use the find all again from exploring what that looked like. I saw that I actually just needed this to find the instance where this happens, the little dash, and it gives me the links. Again, it might be helpful for you guys to see it over here. So this is what when you first pull in the table, what that looks like, what the soup find all does. Then I was able to check length of table as one, then change it into a list of data frames, and that's what gives me this. And I also, again, all of this are steps that you want to do to make sure that the data that you're pulling makes sense. I wanted to make sure I was getting all the columns I expected and that I was getting 50 at a time as expected. This actually was testing how I would end. I changed the offset to a really high number that was beyond what it would include and checked that the length of that would be 0. And that's what I would then use to kill my while loop. So then I experimented a little bit trying to get all of that. So as I mentioned, this is what you end up getting, and I don't care about all of those in particular, so I'm going to get rid of them later on, you'll see. Let's see if there was a good example of what I wanted to show you here. Data pre-work. Here's the original. Oh, no, that's the genre data. Oh yeah, this is the genre data, so where it'll now click into each individual one. So here's where I found that it gave me the links that I wanted to. And then if I turned each individual table into a soup, okay, this is what I would look like. And I found that the links that and again, it's just exploring through here, that the links that I wanted could be found with this. And I tested it and it found me 100 links, which is exactly what I expected because, as I mentioned, each page is 50 and each URL shows up twice. One's in this picture and one's in the title. So if I go back to that, I tested it and I figured out that this is the way I can find each individual one. And as you see, because each one shows up in the picture and the title, each one shows up twice. So that's why my final, in my final loop, I have to figure out the length of my links list, which is 100, and divide by 2 to get to my 50. And then I just want every other URL that it finds and add it into this empty list that I created. So then I create a for loop that for every I between 0 and 50, it'll find it'll find each link and append it into my empty list. So I end up with just a list of all the links, and then I attach that to my data frame as a separate column. That's what concatenate here does. And then at the end of that, I increase my offset by 50, as I mentioned, so that I can go to my next, to the next table or the next page in my table. And that's going to continue going until I finally reach the end, where the table list the find all in soup is not going to find any table. So then the length of table list becomes 0, and that turns keep looping to false. And that ends pulling all the data in. This is a little bit data manipulation, where, as I mentioned, there were a few extra columns I didn't want it. This step removes the index because I didn't want to export that into the CSV. I give titles to each column, and then I just Then for everything at the end, for my 7th column, which is the service, this variable, if you recall, was one of my inputs up here. So it's just a string that says Netflix so that I can say, yes, this is available on Netflix. That's what that pulls in. And then I drop that picture and episodes and track, which are some of the columns that I didn't care about. So trying it out, your final result is this data frame right here, which gives you title, is it TV. Essentially, if it says TV, it'd be a TV showing. If it's an NAN, it is a movie. And I use that when I clean up my data a little bit. It gives me all the scores and all the information from the table. And finally, it gives me the link to go into each individual page. I just explored a little bit, again, make sure that it returns things that I expect. And that's all. So I actually now run it for, let's say, real good. And pulling the table itself actually doesn't take that much. It took about 5 minutes, it looks like, for Prime, which had the most. And again, that returns this individual list. The next step was getting the genre data, which is going to click each individual one. We can skip most of this. This is exploring individual data frames, combining them all into one. Okay, now bringing in the genre and country data. So for this, I created another function. And actually, let's stop here for potential questions before I jump to the next step. Do you have any, Alex?
One question we had, and I think it's, did you scrape the tags? The tags, and Nathan, is that like around the genre? Is that?
Yeah, so that was I got to that before he showed that. Yeah, he was actually following those links through, and yeah, the tags there. It could be some useful data, but it looks like not. But basically, you answered what you scraped by going through it. So thanks.
Excellent. And yeah, as far as the tags, it is something you could follow the same steps to figure it out. You would need to identify how this shows up in the HTML. And it looks like this right here would give you the tags, and you'd have to do figure out a little bit of understanding on how to find it via the class, the href, what the regular expression would be. In this case, it looks like this class would describe it, and and then you could try to pull the list. So you could follow the same steps to pull that in. I did not, as I didn't quite expect that everything would have those tags. And yeah, genre is the main thing I wanted to use. But yeah, you could absolutely do that if you wanted to take this step farther and add even more filters to a dashboard.
Another question we have from Benjamin Conrad is, did you run into any security/access issues, such as did you have instances where the website where Real Good blocked you from accessing it?
I was very lucky that no, I did not. I was kind of afraid that may happen because of the amount of times I would ping it. I luckily did not have to deal with any of that.
And Benjamin, to expand on that further, when you're scraping web data, there are absolutely instances where websites can block you because every time you hit the site, you are taking up some bandwidth. Most websites have something called a robot.txt file that highlights how websites want to be traversed, and also a lot of times websites will have in their terms of service whether or not you're allowed to web scrape them. So like Indeed.com, I was interested in creating a web scraper to pull that job data to do some analytics on job postings, but upon research discovered Indeed.com bans people from scraping the site. So for a project like this, I don't think it's as concerned, but he specifically mentioned like spinning up a server and scraping it on the regular. That could be a problem. One thing to explore with some websites is they do expose APIs, application programming interfaces, that allows you to get at this data in a bit more structured manner. So next question, where did you store the data after scraping it?
Yep, and I think I might have answered that already, but I created some empty data frames where I kept appending. I can show you that back in here. In the original code, I create an empty data frame, and I create individual page data frames within my loop. And then my data frame is going to then concatenate itself to each individual page data frame as each step in the while loop.
And one last question. When the offset is equal to 20,000, the search will end. Why is this the case? Is that because they only allow you to access 20,000? Is there more than 20,000 movies or TV shows in the database?
Yep, and I think I might have answered that after they asked it, but when I was doing my testing, I figured out, and it was actually over here, or my original, where I was looking for the length of my list of tables. Actually, I forget exactly where. Oh no, here it is. Perfect. So I specifically tested if any table returned with getting to the end. So when I do this, my function would go to the same steps, and it would create, using this find all, a list of tables. And often, and back in my original code, usually, since I only expect one table every time, this step over here happens only if it finds one. If the length of that list of tables is 0, that means I've gotten to the end, because when you get to the end, maybe I can try it here, there's just no table found in the HTML anymore. I'm not on just Nef. Oh yeah, I'm just Nef. So let's see, 20,000. Yeah, you get this, and it'll just won't find any table, and therefore that'll kill my loop. All right, good to move on.
One last question. How reliable is Beautiful Soup? Did it ever give you garbage data?
It's been pretty reliable to me, as long as you know how to interpret and what you're looking for in the HTML. I've never had it return anything that wasn't there. For example, it might often, and you might see that in my testing if you go to my other notebooks, I often would get maybe the full HTML, and I had to figure out what specific attributes to pull out of it to get exactly what I wanted. I was trying to look for a good example of that, but maybe just for the sake of time, we'll let you take me on my word on that. But yeah, for example, this is the full table that Beautiful Soup will find. I would need to understand how this works and how the HTML behind it is built, so that I could pull exactly what I wanted. What's really cool is that this is not one of my main responsibilities, but I've ended up having to use at my job Beautiful Soup like 3 times now to parse out HTML files and pull out information that we're interested in.
All good.
Okay, excellent. Let's see. So as I mentioned, I tried out for all of them. I pull everything out. I create my data frames, combine them all together. So I essentially make one data frame that combines each individual one, and that's what this ends up looking like. So I run this for Netflix, I run this for Hulu, and then I pull them all together. So then I needed a function that was going to click on every one of these links that I've pulled and pull out the extra information that I want. And I'm actually going to mention, I'm going to go through this, and then I'll let you know that I actually made a blunder that I had to fix in my troubleshooting. And that's, again, part of understanding the data and why it's so important for you to kind of review the data and make sure it makes sense with what you expect to see. And then go back and pull and correct anything if needed, because sometimes, especially with this big data frames where we're not seeing all the data, it's a little harder to realize, oh no, I'm missing something. So we'll get to that. So this function uses the link to return a dictionary for the value of genres and country, and I'll explain why I ended up doing it that way. But we start kind of very the same steps as before. We use the requests to use that link, and this link right here is the input to this function. which is going to come out of this, is already included in my data frame. So my function finds that link, turns it into a soup. It finds these attributes that, again, I had to inspect the HTML to figure out that that's what the section that included the genre was. It then finds that, and I actually had to do, and this goes back to actually that last question of how reliable Beautiful Soup is. I had to rerun Beautiful Soup on this HTML to get it to get to the next level of what I was looking for. So it then turns the details section specifically into a soup, so that I can use my find all and use this. Again, I had to figure out the regular expression, what would show up. And this says if either movie or TV shows up, then genre, that finds me the genres that I'm interested in. And then it adds that into a list. So then for the way this looks like, and it might be easier if I show you, Webscraping genre data. So here's all my list. This is an example of all everything that was going on in that function. I get a list of links, and then I go to each individual one. And this is why I had to run Beautiful Soup again, because I get, actually, no, I think it happened before that. Yeah, when I get the details section, I end up with a big piece of HTML, and I have to run Beautiful Soup again to get just the genre section that I care about, which was this. Another thing that happened here is, again, understanding the website, that these things could be duplicated, because when you first go into a showing, a listing, you will see, where's genre? You see genres, but they only list 2. If there's more than 2, you can click this and it gets repeated and shows you, any additional ones. So I really only cared about this part. So I had to figure out how to deal with those repeated ones. I figured out through a little Googling and a little research that one method that people can use to get rid of duplicates is turning things into a dictionary, because in a dictionary, it'll, if a key is repeated, it still only shows up as a key once. So then essentially that's what I used. I pulled in that genre section and I turned it into a dictionary by appending each little section in that text that I showed earlier. And this removes the duplicates. Then finally, I combine them all because I end up getting a list. I want to turn that all into one string, which is what I'm going to end up putting into that cell of my data frame. I take some steps where I create those columns so there's somewhere for it to go, and then that's what I did for every row in my data frame that had the links in there, and now this empty columns for the data to go into. I had to run that function for every line in there. This is what took me 40 hours of just clicking Python, clicking on links, pulling data, clicking on links, pulling data. I had to, this crashed a few times because in some cases, if that data is not available, it would find an error and just crash. So that's why I have to use this try and except, so that when that didn't happen, it'll just skip that one line and go to the next one. Finally, this is what pops out with the genres and country column populated for each one. And then I export that, which is what I'm going to put into my Tableau to get to play with that. So this is another good stop for questions, I think. Alex, if we have any?
No questions at this time.
Okay.
But if that's, let's see. Thank you, Georg. Yeah. No, absolutely. So one comment was probably could reduce that by doing some concurrency. So probably having maybe split out and have multiple processes crawling at once. So absolutely. One question is there a bottleneck that contributes to the 40-hour runtime? Does it come down to your internet connection speed and the real good server speed? I
mean, I'd say, yeah, definitely the reliability of your internet will probably have a lot to do with that, and also just your computer and how well it can be running Python, and how much things you have open. I essentially closed everything and let that just run. So yeah, there's a lot of things, technical aspects of the computer or the internet connection that I think would affect that. So if someone else ran this, they have much better hardware than I do. Possibly this would be lower. But the comment about there's probably different ways of having this all running in different boxes or things like that would definitely make this more efficient.
One point I always like to make, though, if it's efficient enough, then it's good. If you don't have those time constraints, and this is more of just like a general comment, earlier in my career, I always tried to like make things run as fast as possible, even though the process would only run once a month. So if your process only has to run once a month, it doesn't matter if it takes 20 hours to run or it takes 5 hours to run, as long as it's fast enough.
Absolutely. I do think anything that takes you, 20, 40 hours, there's leaves potential for things to go wrong in that process. So to some level, I do like reducing that. But yes, I only needed to do this once to get all my data, or so I thought. So this was fine. And that's why I would recommend an approach kind of like what I did here, where I tested all these steps beforehand on just one page of it, or just a few, to understand that it all worked. And when I felt pretty comfortable that my function was set up correctly, that's when I finally ran it in for the whole set, which again, I mentioned included like 25,000 listings. Okay, so if there's no other questions, I'll go quickly into what my troubleshooting was. When I pulled this information, I found that genre or country was not populated as much as I thought it would be. And it's somewhat natural for some of the lesser known or less popular shows that information may not be available. But I went in and looked at some popular things that were missing it and saw that they were they weren't real good. So I had to figure out why that failed in my process. And in my troubleshooting, I actually have a corrected version of this function where I fixed that. And I discovered through just, again, inspecting and playing with certain things or individual listings that in some cases, genre would be there, but not country. But in my original one, if there was an error in that line, it skipped that line completely. Over here, I created this separate section where it finds, is there anything in the country section? And if there's not, then they would just give me a blank. So this allowed it to still give me the genre information in situations when the country was missing. And I actually had to run that for the missing ones, which took, I think, 20 more hours of my time, but it was right. Okay, and that actually, as far as that's what I mainly wanted to focus on, which was the web scraping. So I'll make that the end of my kind of formal presentation. And I don't know if I ran long or if we have time for more questions, or we want to talk about the Tableau or anything like that, then we can take this to wherever people will actually want to take it.
Well, yeah, we are at time, but anyone, as long as you have time, Diego, I'm happy to kind of keep this going. So if anyone has some open questions, we can get into that. So we do have one question. Can you give a detailed example of when and why you use Beautiful Soup at your current analytics job?
Yeah. So in my position as an analyst, we're often working with healthcare providers of all over the nation and trying to understand data for where they're located and how they service patients around them, or so location ends up being a very important data field for us. Where they're located, maybe the zip code, things like that. I've had 3 different situations where my boss or my CEO or someone was able to, I guess they did the web scraping themselves, and they just had this humongous HTML file that they didn't know what to do with. And they essentially asked me to scrape out the data that we care about, which was, for this provider, there's, this is their address, or this is their contact information, or this is their data. So yeah, essentially use Beautiful Soups to get that HTML file and take out the individual pieces of information that we wanted.
Any other questions? Oh, do you have a GitHub handle? That would be, you would be able to get that from his GitHub link. His handle would be the part that's after github.com.
Yep, Diego DAA, I believe is what that would be. Yep. And then again, the link was in the meetup invitation, so you can go straight into the materials for this project and see it there.
What advice would you give someone who is considering Nashville Software School? Ooh, that's a great question.
Nice. Yeah. I think it'll depend a little bit on where you want to go and what your maybe a little bit of what your background is. But overall, I have nothing but great things to say about Nashville Software School. I did a lot of I actually quit my previous job to do this to do Nashville Software School and kind of pivot a little bit into a little bit more technical work than what I was doing before. So I did a lot of research on what was available here in Nashville, and compared it to some things outside of Nashville as well. And I would say definitely do your research. Talking to people like me is great, and it gives you very good information and people's experiences and as a data person, I like to have that data. Some of the other programs I was considering didn't have as much of the data about successes or as good reviews and things like that. So that essentially became a big decisive factor for me. But yeah, Nashville Software School, I enjoy my time there. The instructors are great. I love that it's a nonprofit and one of the few as far as coding boot camps. I'm honestly interested in more of the boot camps that they have, from data science and even web development. So kind of what I would say is figure out what kind of work you think you would enjoy most. And I think you're doing the right things by attending something like this or asking the questions like you are. And then maybe go ahead and contact Nashville Software School if you haven't yet, so that they can maybe, with their experience, walk you through what that work may look like. And maybe web development is for you, or data analytics, or data science, and yeah, take it from there. I think what they offer, they definitely deliver on, which is there's a nice community. As you saw, a lot of the people that are attending tonight are either were my classmates or are people that were that are looking into it or that are current NSS students. So there's a great community. We all help each other out. I still go into Slack and I see people asking for advice and on what they're doing and coming back. The career services was great as far as helping you prepare if you're not great with interviews or resumes or things like that. So yeah, so I think it depends a little bit of where you are and what you're looking for in particular, but keep doing what you're doing as far as asking questions, attend these things, and getting all the data you can to make that decision.
I also just poked on the Nashville Software School website, and they have an analytics and data science information session coming up on December 9th. So I think that would be another great opportunity to just learn more about the program and get introduced. And we also have a couple people on the call today that are both fantastic people. Mary runs the data aspect of NSS, and Mahesh is just, he's a fantastic instructor. So both great people to reach out.
Completely agree. They were my instructors, and I think they did a great job.
Any other questions? Awesome. Well, thank you everyone for coming out. Thank you, Diego, for giving such an awesome presentation on web scraping. It's a fun process, but it is, as I'm sure everyone now can see, it's just trial and error and seeing what works. But it's very, I don't know, I find web scraping to be one of the more rewarding aspects of data, because you're going to this website, you're pulling stuff in, and then you get to create some very interesting analytics as a result. I'll be working on editing this down to a video, and we're getting that posted, but I'll also be sending out the GitHub link, which will include all of his Jupyter notebooks. So thank you, everyone. Hope you all have a good night.
Thanks, Diego.
Thanks everybody for attending.
Bye.
Have a great night and happy holidays.
Thank you. Thanks, everybody.